Okay, I think we'll get started here this afternoon. Apologize for my voice. I'm a little bit hoarse from so far the days we've been having here, but thank you for coming here this afternoon. And I'm going to be talking today about using Windows Azure Pack and Windows Azure websites to help bring the cloud on premises. Now, I'm one of the folks who works on the Azure websites team. We own basically IIS on Windows Server, Azure Websites, which is the public Azure service, as well as websites in Windows Azure Pack, which is the on-premises variant of the cloud service. And it's the last item that I'm going to be talking to all of you about here this afternoon. Now, just briefly to sort of set context, for those of you who've gone to other Windows Azure Pack sessions, this should be pretty familiar to folks. Basically, Windows Azure Pack includes a subset of the public Azure services. Specifically, it supports websites, which is platform as a service offering. It supports virtual machines, which is, of course, standing up VMs in clouds and running them. It supports Service Bus, which is, again, another platform as a service offering that's also available up in the public cloud. And lastly, it supports integration with databases, specifically SQL Server and MySQL out of the box, so that you can very easily set up a private cloud and then be able to also dispense databases for use by the applications that are running on your private cloud. Now, what I'm going to do this afternoon is I'm going to walk through a canonical sort of corporate line of business app that does forms over data. And we're going to start out looking at it running on IIS, and then we'll move it up into an Azure Pack cloud. And hopefully you'll see that by running websites on-prem, you are able to both maintain control over the virtual machines, the data, everything about the app, but at the same time, you get a lot of the benefits of the platform as a service features that come in Azure Pack. So, for example, there are a lot of self-service capabilities that are built into the website service on WAP. And you still retain the ability to integrate with your corporate Active Directory environment. And of course, since you own your own private cloud, you have access to other internal corporate resources like other databases, web services, mainframe integration points, things like that. And then you'll see here how I'll take this application that's running on Azure Pack, and I'll be able to span both the public and the private cloud. And the reason why is that since I'm integrated with Azure Active Directory, I can have my employees log in to a website running on Azure Pack and basically project that identity out into public Azure by way of Azure Active Directory. And that way, my employees can also seamlessly authenticate and access data in other third-party cloud services, such as O365. And you'll see from the perspective of the app itself, nothing really fundamentally changes. It's basically, I've got an ASP.NET MVC app that I don't have to go out and tear it apart or do anything crazy to it to make it work this way. And then lastly, we'll round out the talk with website portability. And you'll see how I'm able to take pretty much the exact same app and run it up in the public cloud on the public Azure website service. And because I've taken the steps to get it to work on Azure Pack, it's a very seamless story to be able to take that same code base and with some very targeted changes, specifically a few config tweaks and the addition of some authentication code specific to Azure AD, and I'm able to go out and run that website out in public Azure. And I wanted to bring up that scenario because it's, the whole public-private cloud thing, it's not necessarily just about making an either-or decision on where you're going to deploy and run an app. You can go out, for example, and choose to do the development and early test work of your applications up in the public cloud, where you can very easily grab resources, make use of them, scale up, scale down, and when you're done, sort of throw away the resources. And then when it comes time to actually deploy the app for real into production, you can choose to deploy it on premises on Azure Pack As a result, you get to maintain control of the data, and you get to deal with and address things like, data sovereignty or privacy issues by being able to run the app and the real live data on-prem. So you can develop in the cloud and deploy on-prem. So with that intro in place, this is a very simple view of the app that I'm going to start out with. Like I said, it's just a meat and potatoes app running on IIS. And then what we'll end up doing is you'll see I'll take the code base for that app and I will go out and redeploy it onto a small Windows Azure Pack cloud that I have running that has the website service on it. And even though I will move that app over to my private cloud, you'll see that we still retain the ability to perform Windows integrated authentication for our browser users, so we don't lose that capability. You'll see that I'm still able to configure my web app to run as an authenticated domain identity, so my web app can continue to authenticate and authorize to downstream corporate resources. And I can also still retain the ability to do integrated Windows authentication to SQL Server. So from a configuration and a security perspective, everything is still working the same way, but with the added benefits of the self-service and manageability features that come from running on Azure Pack. So with that in mind, what I'll do now is switch over to my laptop here and just sort of, as a quick intro, because I'm going to be bouncing around through a bunch of different machines here, I have pulled up off to the side the list of all of the machines that I have running. In this case, they're all running on Azure VMs. So these are all infrastructure as a service VMs running up in our West US region in public Azure. And you can see, or sort of infer from the naming conventions, that what we did is we created a private virtual network up in public Azure, and we joined a bunch of virtual machines to it. And as part of that, we set up a little Active Directory server for our demo. I have a standalone IIS server, which we'll touch on in a little bit. And then I've got a bunch of machines that, in aggregate, make up my little miniature demo private cloud. So I have a bunch of web servers and a lot of the other core infrastructural servers that are necessary to run Windows Azure Pack. And then lastly, I've got my sort of canonical desktop machine, which is where I, if I were an employee working in this hypothetical company, can go out and access my management portal, run my apps from, run Visual Studio, all that kind of good stuff. So for starters, let's just run the IIS version of the app. So at this point, I'm accessing a URL that's inside of my mini cloud, so it's some IIS server, and our basic domain is teched.local. You can see that I didn't have to log in or do anything, and the app's showing some info saying, "Yup, that's me, that's Stefan, you've logged in, congrats." And right now, like I alluded to earlier, it's just forms over data, so it's an MVC app, uses some entity framework, talks to SQL Server, and pulls some data back. So if we flip over to the IIS RDP session, so this is my on-prem, generic IIS server. It's running Server 2012. In terms of how I have the application pool set up, you'll see here that I'm running in the default app pool, and specifically, I've also set it to run as an explicit domain identity here. So again, pretty common thing, right? It's the old trusted subsystem concept where I can go out and have my app tier run as an explicit domain identity, and then I can go out and lock down back-end resources based upon that identity. And then also from the perspective of IIS, the other thing I've done is I've configured the authentication in IIS so that only Windows Auth is actually enabled. So I went out and turned off, Forms Auth, which I might need for ASP.NET. Obviously, I don't let in random users. So I'm able to force people coming into my app that they actually have to do integrated Windows Auth. And then if I flip over to my development machine, and in here I'm in VS, Visual Studio 2013, And if we take a quick look at the actual configuration of authorization and authentication in ASP.NET, so you can see here I've done a very standard configuration for ASP.NET. I've said don't allow in any anonymous users, and I've told ASP.NET as well, hey, you should expect a Windows authenticated user to be passed down to you. So far, so good, nothing too earth-shattering there. I have a canonical app that's using Windows Auth. And now what we want to do is we want to take this app and basically make the necessary changes so that it can actually run up in Windows Azure Pack. So, little segue here. I've got this project actually stored up in public Azure using Visual Studio Online. And what I'm going to do here is within VS, I'm going to say, you know something, I would like to switch from the traditional IIS variant of my source code, and I'm going to switch it over to my Windows Azure Pack version. So that's probably going to take about 20 or 30 seconds in the background to chug through, because when I do that, VS is basically going to look at the different versions of the source code, has to say, hey, did anything change? And then it does some other compilation mumbo jumbo in the background. And that just takes a little while to chug through. So while we wait, I just wanted to show you folks, this is my app defined up here in the Visual Studio Online service up in Azure. And the cool thing about Visual Studio Online is, again, regardless of whether you're doing traditional IIS ASP.NET development or if we're talking here about Windows Azure Pack, this is actually another great way to start leveraging the cloud while still running your apps on-prem. So I've got the entire solution, all of the individual projects, you name it, all sitting here in the source code control repository up in Visual Studio Online. And you can see that when I flip over to the branches that I have showing here, a branch master, which is the public Azure version of this app that we'll see later on in the talk. And then I've got the on-prem, the IIS, and we had an older sort of throwaway version of it. The really great thing, just as an aside about Visual Studio Online, is it makes it a lot easier for you to set up, in essence, a TFS environment in the cloud. Your developers can be spread out around the world in different regions, and they can all be working against the same consistent view of the code base. And then you can choose, when you've built the code, where do you deploy it? Do you put it on-prem or do you put it up in the cloud? So at this point, I'll switch back to my machine running in my little on-prem setup, and you can see it's now switched over successfully to the Windows Azure Pack version of the code. And I'm going to click through and pull up web config here. And from the point of view of what's changed, there isn't a whole heck of a lot that I've done differently. You'll notice that the Azure Pack variant of the app for ASP.NET is still set up the exact same way. I didn't show it earlier in the IIS version of my app, but I have two entity framework connection strings. And the one slight difference between the IIS version and the Azure Pack version, and I'll explain it a little bit later on, is clearly the connection string value is nonsensical, right? Obviously, I'm not going to connect to a database server with a connection string who says dummy value. I did that intentionally because I want to show you one of the benefits you get running on Windows Azure Pack, where you have the ability to externalize configuration settings, pull them out of the app, pull them out of your config files, and instead store them in the configuration databases that we have for websites on WAP. So, okay, that's the extent of sort of what's different here in the code. The first thing we, of course, need is we actually need like a website running in Windows Azure Pack that I can actually go deploy. Now, what I did earlier is I created a shell, basically an empty website. Literally, I came in here into the on-prem customer-facing portal, and I said, hey, website, let's go quick create. And I gave it some name of a website that I wanted to create. So you've probably seen that demo before and variations before. So I didn't want to actually walk through that and wait for that while that happens. So I've already got this site created called Travel AAD. However, there's no content in it. And furthermore, in its current form, it's not actually going to be able to correctly run that IIS application. So I'm going to come in here to the configuration and point out specifically what I need to change. So you'll see here in the on-prem portal, there are options here for enabling Windows authentication for a web app running on Azure Pack, and an option for setting a custom app pool identity. So roughly similar to what I did in IIS, in iNet Manager, I'm going to say this app requires Windows Auth, and I'm going to say this app needs to authenticate, basically the app itself, to downstream resources as a domain principal. And this is actually the domain principal I'm pasting in here right now. And then I'll pop in the password, and we'll go out and we'll save that change. So at this point, Portal is calling up the management API that we have behind the scenes and storing these settings in the configuration database that we have running for Azure Pack. And that's where, instead of, for example, old school application host config, in essence, there's a big hosting configuration database that serves as the quote-unquote metaphorical replacement of app host config. Okay, great. So I've got a site. I think I've clicked the right settings for security purposes. The last thing is, how the heck do I actually get the file content of my web app from where it is in Visual Studio and get it pushed into the website running over on Azure Pack? So what I've done here is click through to a dashboard that we have, and there's an option here called Download the Publish Profile. This is exactly the same as what's up in public Azure. When you click on it, it will download an XML file that has basically the network endpoints of what we call the publisher for the Windows Azure Pack Cloud, and it includes the user IDs and the passwords and everything else. And the nice thing about that is if you're running Web Matrix or you're running Visual Studio, you can come into your web project and you can configure and automatically load up the publishing profile for your app. Now again, in my case, what I had done earlier is I actually downloaded the publishing profile and I already imported it here into VS just to save some time so we don't have to wait for it to get processed and parsed. But you'll notice here it also says FTP, and you'll see in a little bit that you can also take the credentials in that file and you can go use your favorite FTP tool, and whether that's running on Windows or Mac or Unix, doesn't matter, and you can connect via FTP to your website running in Windows Azure Pack. And ultimately, why that works, not that we're going to RDP into it here, but you see this PB Catal setting that's one of the many servers within our Azure Pack Cloud. That is running both a web deploy endpoint that that talks HTTP and HTTPS, and it's also running the FTP server that comes with IIS and Windows Server. And so you can use either one of those to beam in, connect to your website, upload files, and pull files down. So okay, with that intro, let's go out and publish our site up to our cloud. Now, even though in my case, we have to wait while the project builds on my machine and then goes out and pushes it up to my web server. There's about 50 or 70 megs worth of code. The reality is, because we're hooked up to a web deploy endpoint, you can also, for example, have your own on-premises continuous integration and continuous deployment system crank through new changes, compile a new build, and then when it's done, actually go hook up to web deploy and push the changes up into the cloud. So there you go. Once again, I'm now running the exact same app, showing me the exact same data. You saw I didn't get pinged with an authentication prompt. I'm logged in as me, as my corporate credential inside of my enterprise, and my app behind the scenes is absolutely running as the configured domain credential. And to actually prove that a little bit more, what I'm going to do here is pop over to the shared web server, And so again, we'll touch on it a little bit more in a few minutes, but you'll see I have this WS1, WS2. These are actually my 3 web servers for my private cloud. I'm using one of them to run what's called our shared tier, which is like all the apps can end up running side by side on the same server. And the other 2 are for like demo purposes for running my reserved instance tier. Again, it's very similar to the scaling and isolation options that we have up in public Azure. But in this case, because I haven't changed any scaling settings yet, my app got spun up and it's running on the shared server. And so you can see here that sure enough, there's my worker process running, and sure enough, it's running as that configured domain identity. And then similarly, just behind the scenes, this is my quote-unquote on-premise SQL server that we have just set up again, set it up on a VM in the cloud. And if we scroll down here a bit, actually let me zoom out so I can get to it. So if we zoom in here a bit, you can see we set up an integrated Windows login for that identity. So SQL Server will let me log into the server with it. And then similarly, we also went out and said, hey, that domain identity can not only log in, it has rights to my database. So we're able to do Windows auth into the web server, and the web server is able to do integrated auth out the back to my SQL server. Okay, so at this point, I'm going to switch back briefly to the slides. So great, we've gone out and we've taken the exact same website with the exact same code, and we've got it running on Azure Pack. Sort of the question, of course, that we get from customers is, that's nice, but why would I do that? So first off, it is an enterprise-ready product. It does integrate with Active Directory, and we have smoothed out the bumps that were there earlier back in October. So we did interim updates in the last few months so that you can go out and not only run sort of the management plane of Windows Azure Pack in a domain, you can also run, as you just saw, the actual end user apps in a domain, and they work as you would expect. You get very easy self-service scaling options, and I'll actually show that to you in a few minutes. This is actually one of the great sort of productivity savings and benefits that you get. Instead of having to go through potentially heavyweight procedures for customers to be able to say, I would like to run on an extra VM, or actually, no, guess what, I need you to scale me down. All of those procedures are actually baked right into websites on Azure Pack, and they're very easy to invoke and to carry out. You also saw a little bit of the Visual Studio experience. So it's very easy to use VS with websites on Azure Pack. That web deploy integration makes it trivial to go out and push and pull changes between your development environment and WAP. And like I mentioned also, you can do the same thing using Visual Studio Online. And the end result is it makes it a lot easier to get into a cadence where you make changes to your web apps, spin those changes, compile them, and push them out into production or into a dev test environment. And then lastly, even though I'm showing an ASP.NET app, websites on Azure Pack is not restricted to just running ASP.NET. Right? Out of the box, we support a few versions of PHP. We also ship with in-box support for Node.js, so you can fire up web apps running on any of those frameworks. And then, I don't know if anyone out there necessarily still runs it, but we actually also support classic ASP running websites on Windows Azure Pack. So with that quick overview, we'll flip back to my machine here. And what I'll do now is take a look in more depth at sort of some of the options that are available here in Azure Pack for this website. So first thing that just comes to mind, one of the benefits you get is that we collect a lot of monitoring and metrics about all of the websites when they're running on Azure Pack. And so, for example, go hit refresh a few times just to generate some log data. But you can see here where I was using it a little bit earlier today, and you can see it again, sort of the uptick showing here. But we track things like number of bytes of data egress, the amount of CPU utilization that each individual website is racking up. There are actually additional metrics that you can choose to select. And the nice thing about this is not only can you see it shown in the portal if you just want a sort of quick view, but all of this data is actually stored in a historical resource metering database that is also part of the website's offering on Azure Pack. So you can go out and harvest that data, query it, do analysis on it, drive billing off of it, whatever you want. And the great thing is that we have it all separated out website by website. So you can go out and run 20,000 websites and go stick them on 500 machines, and it's okay because behind the scenes in the database, we've got all the data segmented and separated out website by website. So you don't have to go through gyrations of trying to reverse engineer this data. Along the lines of that, in terms of like, hey, how can I get information that's interesting to me about my running website? I'm going to scroll down real quickly here to some of the application and site diagnostics options. So for this site, ahead of time, just so that I get some traffic showing up, I turned on W3C server logging, right? That's probably the most generic meat and potatoes and most heavily used set of log data that comes off of web servers today. So we automatically support that. You don't have to go out and look at some gigantic monolithic set of log files and suddenly try to figure out how to tear it apart and say, oh, these 100 log lines were for that app, but these other 100 were for this other app. We do that automatically. And we have a service actually that runs in the background on every single web server that runs in an Azure Pack cloud. And in real time, we're looking at the incoming log data and we're splitting it apart and streaming it out into different log files that are separated out and segmented for each individual website. And so to sort of make that more concrete, what I did here earlier is I pulled up, in this case, FileZilla, and I already sort of typed in earlier my FTP publishing credentials for my website, and I'll just go out and reconnect us to the publishing endpoint. And you can see here, it starts out sort of at a home directory for my presence, for my website. And when I drill into it, there's actually one directory structure which contains sort of a bunch of information for Git integration if you're doing that, as well as the actual www root. But in my case, what I'm interested in are the log files that are being generated, and specifically in this case, the raw logs. And so you can see here, I have one log file that's created. You notice the naming convention, w-catal, from my RDP shortcuts that I have. That's the quote-unquote shared web server. And if I pop this guy open and take a look at it, zoom it out so it's a little bit clearer, and we'll turn off word wrap, and you can see, yep, sure enough, that looks a heck of a lot like your canonical W3C logs. So, URLs, client IPs, status codes, you name it, everything is in there. So, if you have corporate processes, analytics tools, software packages, you name it, that today go out and ingest W3C logs and do all kinds of processing on it, it should be very straightforward to be able to continue to use those tools using these log files as the input. Now there's some other diagnostics options. Again, I'm not going to actually turn them all on and walk through them in detail, but I wanted to touch on them briefly. The detailed error messages, that's basically the IIS error page, if you've seen that from on-prem IIS. So if you happen to run into a problem and the app just keeps on throwing errors and you're sort of tearing your hair out, you can turn on the detailed error message option, and then you can go right back to that directory structure I showed you in the FTP tool, and you'll actually see we emit the HTML file to the file system that today you would normally see in the browser. And I've actually used that with my folks a few times when we were debugging setup problems. And for example, we made the canonical mistake of screwing up some web config settings. And once we turned on the detailed error messages option and pulled down the archived HTML files, we're like, oh, look, there's that generic IIS error that says, like it doesn't recognize configuration section foo, because guess what? We fat fingered it and we hadn't typed it in properly. And then the more advanced option, the failed request tracing, some of you may be familiar with that on regular IIS. It's referred to as FREB. It's basically the ETW event-based tracing option. You can turn it on, and again, similarly, into that directory structure we saw in the FTP viewer, you will get the voluminous and chatty FREB logs generated so that you can actually see all the pipeline events and see where the errors are getting thrown. So again, another great way of being able to troubleshoot what's going on without having to necessarily fall back to, old school printf debugging. And then lastly, the application logging option. That's there specifically, for example, for .NET apps that write trace information using the system diagnostics types. So if you have any code or third-party libraries that log information using the system diagnostics infrastructure, and you have application logging turned on, you will see those files hit the file system that you saw there in FTP, and again, then you can pick them up and look at all the details that are being emitted. So, okay, that gives you a quick overview of the logging options. I wanted to just sort of walk through quickly a lot of the salient and interesting things here on the configuration tab. Like I mentioned earlier, we have support for a lot of frameworks, so it ships with both 3.5 and 4.5 .NET Framework support. Actually, if you're running on 2012 R2 for your VMs, that will actually be, I believe, .NET Framework 4.5.1. So all of the, all of the mainline versions of .NET are there and available. We ship with PHP versions 5.3 and 5.4 already available and pre-installed on your web servers. There isn't actually an option here that you have to click on for Node.js. We just install the latest version of Node for you. So if you have Node.js apps, don't worry, you can just go deploy them up onto Azure Pack and they'll run without a problem. Now, one thing I wanted to call out, and we'll actually come back to some of these in a little bit, notice there are some very interesting options here, like, for example, platform bitness, which a number of you probably care about because you have 32-bit apps and you have 64-bit apps. And yet, in this case, gee, it's grayed out. So I'll touch on that in a little bit, but this is basically a way that you can set up websites on Windows Azure Pack and basically decide what options are actually available to different developers in different websites. So you can actually restrict the kinds of functionality that are available. And the same deal exists here for SSL certificates and custom host names. And you'll see in a little bit, we'll actually set up a custom host name and bind an SSL cert and switch this app over to running against a vanity domain protected by SSL. So we talked about diagnostics. So settings, app settings and connection settings. So you remember earlier I showed you the web config for the Azure Pack version of my site, and I had those somewhat nonsensical connection string values. The reason why the app actually runs just fine and is clearly able to connect to the database and find it is that we're using the exact same key value management that's up in public Azure. So what you can do is you can configure app settings and connection strings, give the keys and the values to us. We will encrypt them and store them in the hosting configuration database that's associated with your website. And then at runtime, we will automatically include both sets of key value pairs and inject them into the environment variables of the W3WP instance that's running your website. And additionally, specifically for .NET, we'll also use reflection underneath the hood, and we will plumb these settings into the .NET application settings collection and the .NET connection strings collection. And that's why this ASP.NET MVC app worked, because underneath the hood, it's using Entity Framework. Entity Framework was set up to use these connection strings. And if I click on Show Connection Strings, you'll see that, sure enough, I have set up a standard SQL Server connection string using integrated authentication against my back-end database. So I'm still working the exact same way I did with plain old IIS, but I was able to pull those connection strings up and out of my app code and app config and instead get them baked into the configuration store for Windows Azure Pack. This is also a really good practice to use if you're thinking about running sites either up in public Azure or on Windows Azure Pack. Because by going out and externalizing these configuration settings, you can do the exact same thing up in public Azure, and you don't have to change your code because your configuration settings are actually sitting here in the configuration store. And then one last thing I wanted to touch on, you'll notice here, okay, I scrolled to the bottom of my configuration options, but I'm going to pop out here for a second to the public Azure portal, and we'll go beam into basically the Azure variant of my application. And I wanted to call out that there is actually support in Windows Azure Pack for one additional feature. It's basically virtual applications and directories. There's one small difference, which is in Azure Pack, we haven't actually updated the HTML UX of the portal that we were looking at. However, the back end of websites supports the ability to define custom virtual directories for your application. And it also supports marking those virtual directories as quote-unquote applications. So again, if you've done a lot of operations of .NET apps, you know that some .NET applications have a virtual directory structure, but some of the subdirectories are actually their own little self-enclosed apps. And it's actually very important in like traditional IIS to mark those subdirectories as apps, aka app domains. So what I'm showing you here, you can do the same kind of thing on websites on Azure Pack. You just need to use the management APIs through PowerShell to configure them. And we are working on being able to update the portal in the future to expose these settings. Okay, so I'll switch back to my RDP session here. And at this point, let's talk about scaling, which is one of the really nice features that you get when you run on Azure Pack. So Windows Azure Pack and websites specifically has the concept of dividing up your websites into different scaling modes. And you can see the three names of them here. It's actually completely up to you in terms of what you choose to turn on and off in these different website modes. In my case, what I'm going to do right now is I'm going to say, let's go to the quote-unquote premium or reserve tier. And for my site, now what that allows me to do is it allows me to choose the specific virtual machine size that I might want to run my sites on, as well as the number of instances that I want to run them on. Now in my case, for my demo, I just want to move my site off of the shared web server tier and move it up to the reserve tier running on a single small VM. Now the nice thing here is when I make this scaling decision and make this scaling change, it's actually happening in real time. I don't have to go out and start configuring individual web servers to move the website around to a different machine. I don't have to worry about how I'm going to synchronize application host config across different machines. Because all of the configuration sits inside of a database, literally all that's happening is I'm changing some flags in a few rows, and I'm changing some routing information on the front-end ARR tier, and then committing that all to the database. So I'll go out and I'll say, great, yep, we're done on that. I will close down the browser window we had. I will pull up a brand new browser window, and once again, we will navigate to the version of my app running on Windows Azure Pack. And again, because it's an ASP.NET app, it'll take a little bit to warm up and run, but in a few seconds, it'll actually come up and be running again. And I'll come back to it in a sec there, just so that you see that that is the case. What I wanted to call out here back on the configuration page, though, was take a look at what happened to the platform and WebSockets options now that I scaled up. They're not grayed out anymore. I now have the ability to, if I so choose, say, I want this website to actually run in a 64-bit version of W3WP instead of a 32-bit version. And I can also, if I so choose, I can turn on support for WebSockets, which we fully support on WAP, and all the certificate, SSL binding, and custom host name options have also been ungrayed out. So let's actually talk about that for a little bit. And then here, just real quick, so sure enough, my app's still up and running, right? I didn't have to do anything else for it to be able to scale and move over to its own dedicated instances. Now, an interesting thing here, though, is I'm wondering what instance is my website actually running on. So what I've done here is I've jumped over to yet another machine, and now I'm running on what's called the management portal. So this is the HTML portal for the cloud administrator. This isn't the portal that the end customer or your employees uses. This is the portal that you use as the owner and administrator of the actual clouds. And what I'll do here is I'll click into my website cloud and drill into it. And specifically, I'm going to take a look at the roles, aka all of the individual VMs that I have set up and running. So you can actually see here the names, right? They look very familiar to the names you see here on the left-hand side with all of our RDP shortcuts. And you can see we basically got one VM set up for each of the primary Windows Azure Pack instances, as well as 2 reserved instances off to the side. And if I look at the site count, it appears that I've got one website here running on the machine WS2-Catal. So let's go over here and go into the RDP session for that number 2 web server. And sure enough, now I'm actually running the website on a completely different web server. And you can see it's still running with the domain credentials and everything else as expected. So, you know, to sort of drive home the point, I didn't have to sit here and worry about copying content around. I didn't have to synchronize anything. This is just the sort of seamless scaling experience that you get automatically when you run your websites on Azure Pack. And it substantially reduces the management overhead of having to make scaling decisions and moving sites around. Now, the other point that I wanted to show while we're here in the management portal is, you know, I had mentioned earlier, right, the 32-bit, 64-bit decision and the WebSockets options were all grayed out, and then they weren't grayed out. And so, like, how the heck did that happen? So in Azure Pack, there's this concept of a plan. And it was sort of called a plan because it had its gestation originally for public web hosting providers who might be reselling their services to end customers. And so sort of in that parlance, it was talking about a plan, you know, much like you have, for example, a cell phone plan, and what are all the features you have on the plan, and what can I turn on and off? And that's actually the mental model for the plans. It's a way that each individual compute workload in Windows Azure Pack has a way to express and define the features that are available and which features are turned on or off depending upon which tier of service the customer's site is in. So in our case, for websites on Azure Pack, you'll see here intro, basic, reserved. Those are the exact same 3 values that you see as an end customer when you're in the admin when you're in the tenant portal and you're looking at website mode. So there's intro, basic, and reserved, and behind the scenes there's intro, basic, and reserved. And so that's how those 3 map to each other. And you can see for websites we probably got about 20 different settings. A lot of them are quota related. So how much CPU time are we going to allow a website to burn? How much memory footprint are we going to allow a website to consume? And those are there so that you, for example, if you're running on a shared server where you're putting a lot of different customer websites onto the exact same VM or the exact same physical piece of hardware, you have a way to be able to gate them and say, you know, I'm not going to allow someone to upload a little 5 kilobyte app that runs a for next loop and burns the CPU forever. Instead, you can go out and define, for example, a CPU quota constraint. And behind the scenes, we actually have a quota management service running on every single web server. And we're periodically checking and sampling the CPU and the memory and the network egress metrics. And so there's some amount of lag, but within a minute or two, we'll detect the fact that a website has exceeded its defined quota, at which point we will shut it down. You don't need to be involved in that. We'll do that automatically. And we'll basically put up a web page saying, sorry, this site is unavailable. So it's a much, much easier and much more automated way of corralling a bunch of different websites onto a shared infrastructure and running them in a way that no individual website can sit there and completely overrun the resources of the shared machine. And then the other thing that a plan lets you define is, like I said earlier, whether or not a feature is even available in the first place. So, for example, you can see here subscription 64-bit worker process support. And you can see that sure enough, the first two columns, say for the basic and the intro tier, it's not available. You can't use it. But if you're running in the highest end tier here, in the reserved tier, you are allowed to go out and run in 64-bit mode. So again, you can parcel up some of these heavier duty features, and when you have your employees creating sites, you can say, well, guess what? You're only allowed to run in the lower tier plan, and so you're only going to be running 32-bit processes or things like that. So that's how ultimately the plans, the quotas, and the features from the point of view of the administrator intersect with what I, as the customer, can actually select and set up here in the customer-facing portal. So in my case, since I already decided that yes, I want to run in the reserve mode, let's do a couple of quick things here. First off, I'm going to go out and run in, of course, Microsoft's favorite demo domain, which is contoso.com, and I'll say, yes, I want to add this as a recognized custom host name for my website. And part of the reason why that'll actually work is on our Active Directory server, we just sort of fiddled around with it a bit, and we did throw in, a sort of contoso.com domain that we just mapped directly to the IP address of our little private cloud. So that's how ultimately we can run in sort of two completely different domain suffixes, and yet from the point of view of the browser, I can actually resolve the requests and they'll make it to my web server. The other thing I'm going to do is, again, I'm running inside of a company. Chances are for a certain set of my apps, I actually want them to be secured behind SSL. So I went out and created an SSL cert, in this case issued by the CA service that's running on the domain controller. So we'll go out and we'll upload that cert. And now that I've done that, what I can do is I can say, hey, for my site, if requests come in on www.contoso.com, then I want you to go out and support SSL with this certificate. And you can actually see there are two options. There's SNI SSL and IP-based SSL. So today I'm just going to use SNI SSL because that's the SSL option that works pretty much automatically out of the box. IP-based SSL, there is some quote-unquote assembly required. And the reason why I say that is Windows Azure Pack, right, we don't actually know about how you've allocated IP addresses within your corporate network. So there is documentation on Azure Pack that explains how to write, there's basically a PowerShell integration script where you can add in code that at the time that somebody here says, I want IP-based SSL, we will call out to the PowerShell script you write, and we'll basically say, here's the host name, here's some other information, let me know what IP address I should actually bind this website to. And the idea is that you can then, for example, call out to an upstream load balancer like an F5 device, and you can go program it with a specific IP address and a host name binding, and then come back to us and say, great, I'm done provisioning that, here's the IP address I want you to run the site with. And there are actually two general approaches for supporting IP addresses on websites in Azure Pack. One is you can basically assign a range of port numbers on our front ends, and you play the old trick where you tell your upstream, your F5 device as an example, hey, if a request comes into 1.2.3.4, guess what? Instead, forward the request to the shared IP address of the Azure Pack cluster, but send it to a specific port number. And that's like the magic port number for this specific website. And the other option is a sort of more traditional one, which is just, hey, I'm going to give you a unique IP address to every single website, in which case what will happen is all of the front ends, that in our case they run ARR on IIS, all the front ends will get that IP address propagated to it, and they have to actually be bound to the NICs on those front ends. But in this case, like I said, we only have a single IP address set up for our cluster. So that means for SSL, we need to go with SNI. And I will close down that browser window. So great, it went out and it saved the changes. We just take a quick look-see. Great, there it is. So once again, let's come in here to our browser. And in our case, there we go. Okay, let's go to the HTTPS endpoint. And let's go to contoso.com, which is our custom domain name. So again, that'll take a little bit to spin because of the changes we made, but when it comes back up, you'll see that yes, sure enough, we are able to resolve the custom host name to the app running in our cluster, and furthermore, we are successfully running underneath SSL because we have our certificate here for contoso.com, which, like I said, was issued by the CA we have set up on our AD controller. So at this point, I think you see the swath of everything that you can do, even though the website is running on Azure Pack. I can still integrate correctly with AD. I can lock it down with SSL. I can set it up with custom host names if I care about it. And yet, from the point of view of setting it up, for me, the customer, what did I do? I typed in a host name and uploaded a PFX, and blammo, everything is working. And again, that's sort of one of the central themes of websites as a service on Azure Pack, is that it makes it much, much easier to delegate tasks that previously may have required administrative intervention, and instead you can just sort of delegate them to your customers, to your employees, and they can do self-service operations against their website. One other just sort of note that I wanted to call out before I switch back to the slides, we get questions from time to time from customers asking us, are there any special VM or virtualization requirements to be able to run the websites service on Azure Pack? And the answer is there's actually no restriction and there's no requirement or need, even for Hyper-V, to go run websites on Azure Pack. So for example, back in the day when we first started building this product 2.5 years ago, it was just a spaghetti's nest of servers running underneath a couple of developers' desks. And the whole time we actually built up the product, we didn't really care about, does it work with Hyper-V, or does it run on AWS, or what about VMware? All we care about is all of our websites and all of the web servers we connect to just needs to be something with an address that we can connect to and install our management software on. So you can absolutely go out and run websites on Windows Azure Pack and have the VMs coming from VMware. Or you can do what I have up here. You can go set up all the VMs on a private hosted service running up in Windows Azure, and it'll run fine. And similarly, earlier demo versions that we used at other conferences for Azure Pack were running out on third-party VM providers. So you could go run it on Rackspace or another provider. So there's no restriction in terms of the hardware or the virtual machine technologies you use if you care about running websites on Windows Azure Pack. Okay, so let's switch back to the slides here for a sec. So this is sort of the mini architectural diagram of where we are right now with this app. And what I'm going to do next is basically click a little bit deeper into the app and show you that actually the app we're running, even though it's running on-prem, it's integrated with Azure Active Directory, and it actually leverages Azure Active Directory to let me reach out and talk to third-party cloud services and make use of, for example, SharePoint Online, which is part of Office 365. And it also, this little app will reach out and talk to web services running over in Salesforce. So I'll once again bounce back to the demo environment, and we'll come over here to, let's see, the browser. Whoop. All right. Okay, it looks like I accidentally closed my browser down on it, so we'll just beam back in here to contoso.com, pull it back up again. And now what I'm going to do is say, great, let's go create a new travel request. So this is just a little app to simulate, maybe customers are going out and traveling to a lot of different customer accounts. And in this case, when I clicked on the drop-down, this information is actually being sourced from a developer account that we set up out in Salesforce. So the website's running here on-prem. I'm logged in as me, but because of the fact that I also integrated my on-prem Active Directory with Azure Active Directory, and because Azure Active Directory supports sending security tokens to Salesforce, what just happened right there when I clicked in that drop-down is ultimately there was a security token issued by Azure Active Directory for me that was sent over the pipe by my web server to Salesforce. Salesforce used that security token to authenticate and authorize me to my developer account and said, yes, I will actually allow you to go query your customer account data. And then furthermore, it's not just a one-way trip. I can not only query the data, but in my case, because it's my developer account, I'm actually a full admin on it. And so I can actually write data back into Salesforce as well. So for example, let's see here, Edge Communications. Okay, I think I have my Salesforce developer portal pulled up here. We'll click into the Edge Communications demo account. And if I scroll down a little bit here, you'll see literally just a few seconds ago, we went out and from our app running on Azure Pack wrote what's called a Salesforce note object back into Salesforce by calling their REST APIs. And then similarly, not only did our app go out and create information in a third-party web service, if I come in here, you'll notice there's a SharePoint link. So I'm going to click through that, and you'll notice at this point, it's, Office is asking me saying, yeah, who are you? And this is actually my UPN identifier, stephsch@mycompanylocal.com. This is the UPN suffix and representation of my account, my Active Directory. And I can go ahead and from there, you see there's a couple of redirects back and forth, but I never typed in a password. It just blipped me in to my old 365 tenancy. And the reason for that, again, is because I've set up Office 365 as one of the endpoint services that I am willing to allow my corporate identity to be used for authentication and authorization purposes. And you can see here, right on the highlighted line, we created an entry in a SharePoint list. And so from this point, you can go out and have your SharePoint developers build some workflow or some business logic that's driven off of it. And for the heck of it, we also dropped a document into the document library. So again, the ASP.NET MVC app just sort of rendered a little bit of Word XML on the server and then went ahead and posted it and uploaded it into the SharePoint document library. Now, like I said, the reason why that's all sort of hanging together there is I'm relying on Azure AD as sort of the glue to make all of this work. So right now I'm back up in the public version of the Azure portal, and I can see here I've got two directories. One of them is sort of this sort of default free directory you get whenever you sign up with a subscription in Azure, but we went out and created a specific directory for our purposes, and we set it up so that the mycompany-local.com Active Directory domain will integrate and will synchronize with its counterpart here in Azure AAD. And in fact, right, if I flip back here to my on-prem setup, and if I take a look at my users, and let's go scroll down here to me. Remember earlier, right, there's my account in mycompanylocal.com. So that's the representation of my domain up into the public cloud, and I've already set it up and verified it with Azure AAD. And then in addition, what we did is we turned on directory integration. So there's a tool called DirSync, short for directory synchronization. We have it installed on our demo AD domain controller, and it synchronizes periodically and makes sure that the user principals in my corporate domain also are represented up in the Azure Active Directory domain. So that's how we're able to at least say, hey, there's Stefan in the on-prem AD, now there's Stefan in the Azure AD, and then the last step is we can now jump off of that and use that as a springboard, and from there we can say, well, guess what? Now that I'm Stefan in Azure AAD, you can go present that credential to SharePoint Online, and I will run as me whenever I'm doing any CRUD operations against SharePoint. And similarly, you can see here we also did the setup work with Salesforce. So this is also why I can present my identity as me out to Salesforce. And again, it can go out and authenticate and authorize me. So I know that's sort of a lot of concepts strung together, but that's ultimately, even when you're running an app on premise, that's ultimately how you can reach out and touch and use the cloud, even though, hey, guess what? You're really a private cloud app. In a way, for me, on my team, I don't know that we really think about it anymore about public versus private cloud. We just sort of look at it as you wrote a cloud app, some pieces of it are going to run on VMs or raw metal that's under your control. Some of it is going to run on a service. Maybe the service is running in a business department down the hallway. Maybe it's running in a Microsoft data center 1,000 miles away. From our point of view, from an app development model and an architectural point of view, who cares, right? It's an app, I've got an identity, and I can go out and do stuff against a variety of different data stores using that identity. So, okay, we'll switch back here to the slides and go over one last thing. So, now what I'm going to do, just to sort of close the loop on all of this, is show you the same app, almost the same app, a couple of caveats, running up in public Azure. And one of the ways I'm able to get that app running up in public Azure is that I'm relying on a feature that just got released here. Currently it's in preview mode, but it will eventually end up GAing, called Azure Hybrid Connections. It's part of the BizTalk sort of universe. And the main thing it does is it makes it very easy for a website to reach back in on premises and connect to a SQL server, a MySQL server, an Oracle server, or HTTP or HTTPS endpoints that are running inside of your corporate firewall. And what this is going to allow me to do is to say, guess what? My app is now going to run up in Azure, and it's going to look and function pretty much the same, with the slight difference that it will use SQL Server authentication and Azure Hybrid Connections to reach back out and call up my on-premises database. So let's take a brief look at that. First off, I'm going to come here to my laptop specifically, and just to sort of keep things straight, we will go to the public Azure version of the site. So mycompanylocal.com. And because I have ADFS running on my domain environment, I am able to go out and do forms authentication using my corporate credential, even though I'm running here basically over the public internet. So in this case, great, I've got my hastily customized ADFS login page for my corporate domain. The corporate domain goes out and realizes, hey, it's Stefan, so I'm still logging in with the same user ID, same password. Me, as my company, I can still gate access to my app because I'm the one who owns the ADFS endpoint. I decide who's actually going to get authenticated there. Once I pass the authentication, ADFS redirects back to Azure Active Directory. Azure AD says, great, I'll issue a security token. And oh, by the way, I will issue a security token to this app that's running up in the cloud. And if we actually come back here and take a look at my Azure AAD setup, that's actually the last app here you see in the grid. So I also said, hey, Azure AAD, it's okay to present a security token to this application. And that's how I'm able to lock down my public Azure version of the application running up here in the cloud. So it looks like I'm running against the exact same app here. Let's go out once again and create a travel request. And in this case, let's see, I'm going to go with P. So we'll go with pyramid construction. So we'll give it an address. We'll say, great, let's go out and create that travel request. So far, so good. Looks like great, there's pyramid construction. Let's flip back over to my on-prem world. And let's go over here to my app and back up a bit. And you can see, sure enough, I'm pointed at the exact same database. There's pyramid construction. There's the record that was actually created from the customer running out on the public cloud against the public Azure version of my site. And then similarly, if I blip in here to my RDP session against my on-premises SQL server and just run a query against the database table that has all of my travel requests, you see, yep, sure enough, there's Edge, which we created using the on-prem version in Azure Pack, and there's Pyramid, the row that we inserted using the public Azure version of my app. So, the driving point here is, like I said, if, and granted, I mean, it's an if with a caveat, but if you're able to do what I would call cloud-first development and cloud-first architecture, where you first think about how you're going to build a new app, or for that matter, overhaul an existing app, so that you know it will play well in a cloud environment. You don't necessarily worry about whether it's public or private on day one. You just worry about making an app that's friendly for the cloud and makes use of the cloud. Then you have the freedom of choice to be able to say, okay, now that I've got this app working, do I need to run it on-prem? Can I run it in public Azure? Or for that matter, here's a crazy idea, maybe I run it in both. Maybe I have the version of the app that all my employees use when they're actually at home base inside of the corporate network. And maybe I have a slightly stripped down version of the app that I have accessible running up in public Azure, in which case maybe I can deploy that app around the world in all the different Azure data centers. But the main point here is you think about the cloud first from a development and an operational and architectural perspective, and you take advantage of your existing Active Directory domain assets so that you can actually use your corporate creds all over the place. So, okay, let's close out things this afternoon here. So I won't go over this slide in more detail, but it is there for folks to take a look at. Also, a shameless plug for the Azure Hybrid Connections folks. They have another session, a repeat going on, I believe, tomorrow afternoon. It's after lunchtime. I think it's roughly the 1 p.m. slot over in the Hilton. So if you're curious about that technology, which is what I leveraged there in the last demo to connect to SQL Server, definitely go on over to the Hilton tomorrow afternoon for that talk. Just to sort of wrap things up, so you got a good quick overview of the service capabilities, the platform as a service functionality that you get when you run websites on Windows Azure Pack. Hopefully you got a good idea that as a first step, you can take your existing IIS applications and you can plan and move those into Windows Azure Pack. Because from the point of view of what's going on at a very low level, you're still running on a bunch of IIS machines. It's still got .NET Framework and a lot of other familiar web app development frameworks running on it. And we fully support running on and inside of a corporate AD environment. And then from there, once you're up and running in a private cloud, you can start thinking about spanning that application out into public Azure and using public cloud resources. And you can also, sort of rest easy knowing that you don't have to worry about going to public Azure right this nanosecond or tomorrow. The fact that you're running in websites on Azure Pack means you've already figured out how to run in a cloud environment, and you can sometime later on down the road think about what it would mean to run those apps up in the public cloud as well. So we've got a few links here again when you're back home. And if you want to look at some of the recorded sessions, there's some great info here, both on the companion Azure websites, as well as some other info on Azure Pack. I also threw in a bunch of links about some of the things I know customers have asked about, specifically when they've been looking into installing websites on Windows Azure Pack. So for example, info on our network topology requirements, because we know that firewalls and ports, things like that are important for you to know when you're planning it out. Another one is we've done a lot of work to make it easier to set up Azure Pack in a disconnected environment. So there is a way that you can slurp down websites and Windows Azure Pack onto a machine, and then you can go to a completely closed off set of servers that have no internet connectivity, and you can say, great, these servers, here's where the bits are on my internal share, go set up my private cloud. So that's pretty much the talk, folks. Thank you very much for coming out here this afternoon. And as you've heard before, definitely when you have time, please do fill out an eval. If you're lucky, you will win an Xbox One, which means you can play Titanfall when your boss isn't looking at work. So again, thanks for coming out, everyone. Trusted subsystem concept where I can go out and have my app tier run as an explicit domain identity, and then I can go out and lock down back-end resources based upon that identity. And then also from the perspective of IIS, the other thing I've done is I've configured the authentication in IIS so that only Windows Auth is actually enabled. So I went out and turned off, Forms Auth, which I might need for ASP.NET. Obviously, I don't let in random users. So I'm able to force people coming into my app that they actually have to do integrated Windows Auth. And then if I flip over to my development machine, and in here I'm in VS, Visual Studio 2013, and if we take a quick look at the actual configuration of authorization and authentication in ASP.NET, so you can see here I've done a very standard configuration for ASP.NET. I've said don't allow in any anonymous users, and I've told ASP.NET as well, hey, you should expect a Windows authenticated user to be passed down to you. So far, so good, nothing too earth-shattering there. I have a canonical app that's using Windows Auth. And now what we want to do is we want to take this app and basically make the necessary changes so that it can actually run up in Windows Azure Pack. So, little segue here. I've got this project actually stored up in public Azure using Visual Studio Online. And what I'm going to do here is within VS, I'm going to say, something, I would like to switch from the traditional IIS variant of my source code, and I'm going to switch it over to my Windows Azure Pack version. So that's probably going to take about 20 or 30 seconds in the background to chug through, because when I do that, VS is basically going to look at the different versions of the source code, has to say, hey, did anything change? And then it does some other compilation mumbo jumbo in the background. That just takes machines that I have running. In this case, they're all running on Azure VMs. So these are all infrastructure as a service VMs running up in our West US region in public Azure. And you can see, or sort of infer from the naming conventions, that what we did is we created a private virtual network up in public Azure, and we joined a bunch of virtual machines to it. And as part of that, we set up a little Active Directory server for our demo. I have a standalone IIS server, which we'll touch on in a little bit. And then I've got a bunch of machines that, in aggregate, make up my little miniature demo private cloud. So I have a bunch of web servers and a lot of the other core infrastructural servers that are necessary to run Windows Azure Pack. And then lastly, I've got my sort of canonical desktop machine, which is where I, if I were an employee working in this hypothetical company, can go out and access my management portal, run my apps from, run Visual Studio, all that kind of good stuff. So for starters, let's just run the IIS version of the app. So at this point, I'm accessing a URL that's inside of my mini cloud. So it's some IIS server, and our basic domain is teched.local. You can see that I didn't have to log in or do anything. And the app's showing some info saying, yup, that's me, that's Stefan, you've logged in, congrats. And right now, like I alluded to earlier, it's just forms over data. So it's an MVC app, uses some entity framework, talks to SQL Server, and pulls some data back. So if we flip over to the IIS RDP session, so this is my on-prem, generic IIS server. It's running Server 2012. In terms of how I have the application pool set up, you'll see here that I'm running in the default app pool, and specifically, I've also set it to run as an explicit domain identity here. So again, pretty common thing, right? It's the old. You can go out, for example, and choose to do the development and early test work of your applications up in the public cloud, where you can very easily grab resources, make use of them, scale up, scale down, and when you're done, sort of throw away the resources. And then when it comes time to actually deploy the app for real into production, you can choose to deploy it on premises on Azure Pack. As a result, you get to maintain control of the data, and you get to deal with and address things like data sovereignty or privacy issues by being able to run the app and the real live data on-prem. So you can develop in the cloud and deploy on-prem. So with that intro in place, this is a very simple view of the app that I'm going to start out with. Like I said, it's just a meat and potatoes app running on IIS. And then what we'll end up doing is you'll see I'll take the code base for that app and I will go out and redeploy it onto a small Windows Azure Pack cloud that I have running that has the website service on it. And even though I will move that app over to my private cloud, you'll see that we still retain the ability to perform Windows integrated authentication for our browser users, so we don't lose that capability. You'll see that I'm still able to configure my web app to run as an authenticated domain identity. So my web app can continue to authenticate and authorize to downstream corporate resources. And I can also still retain the ability to do integrated Windows authentication to SQL Server. So from a configuration and a security perspective, everything is still working the same way, but with the added benefits of the self-service and manageability features that come from running on Azure Pack. So with that in mind, what I'll do now is switch over to my laptop here and just sort of, as a quick intro, because I'm going to be bouncing around through a bunch of different machines here, I have pulled up off to the side the list of all of the Okay, I think we'll get started here this afternoon. Apologize for my voice. I'm a little bit hoarse from so far the days we've been having here, but thank you for coming here this afternoon. And I'm going to be talking today about using Windows Azure Pack and Windows Azure websites to help bring the cloud on premises. Now, I'm one of the folks who works on the Azure websites team. We own basically IIS on Windows Server, Azure Websites, which is the public Azure service, as well as websites in Windows Azure Pack, which is the on-premises variant of the cloud service. And it's the last item that I'm going to be talking to all of you about here this afternoon. Now, just briefly to sort of set context, for those of you who've gone to other Windows Azure Pack sessions, this should be pretty familiar to folks. Basically, Windows Azure Pack includes a subset of the public Azure services. Specifically, it supports websites, which is platform as a service offering. It supports virtual machines, which is, of course, standing up VMs in clouds and running them. It supports Service Bus, which is, again, another platform as a service offering that's also available up in the public cloud. And lastly, it supports integration with databases, specifically SQL Server and MySQL out of the box, so that you can very easily set up a private cloud and then be able to also dispense databases for use by the applications that are running on your private cloud. Now, what I'm going to do this afternoon is I'm going to walk through a canonical sort of corporate line of business app that does forms over data. And we're going to start out looking at it running on IIS, and then we'll move it up into an Azure Pack cloud. And hopefully you'll see that by running websites on-prem, you are able to both maintain control over the virtual machines, the data, everything about the app, but at the same time, you get a lot of the benefits of the platform as a service features that come in Azure Pack. So, for example, there are a lot of self-service capabilities that are built into the website service on WAP. And you still retain the ability to integrate with your corporate Active Directory environment. And of course, since you own your own private cloud, you have access to other internal corporate resources like other databases, web services, mainframe integration points, things like that. And then you'll see here how I'll take this application that's running on Azure Pack, and I'll be able to span both the public and the private cloud. And the reason why is that since I'm integrated with Azure Active Directory, I can have my employees log in to a website running on Azure Pack and basically project that identity out into public Azure by way of Azure Active Directory. And that way, my employees can also seamlessly authenticate and access data in other third-party cloud services, such as O365. And you'll see from the perspective of the app itself, nothing really fundamentally changes. It's basically, I've got an ASP.NET MVC app that I don't have to go out and tear it apart or do anything crazy to it to make it work this way. And then lastly, we'll round out the talk with website portability. And you'll see how I'm able to take pretty much the exact same app and run it up in the public cloud on the public Azure website service. And because I've taken the steps to get it to work on Azure Pack, it's a very seamless story to be able to take that same code base and with some very targeted changes, specifically a few config tweaks and the addition of some authentication code specific to Azure AD, and I'm able to go out and run that website out in public Azure. And I wanted to bring up that scenario because it's, the whole public private cloud thing, it's not necessarily just about making an either or decision on where you're going to deploy and run an app.